Our first speaker from LVK is Keita Kawabe. He'll be giving us an update on a survey he sent out to the actual community, I think last month, about LVK's RRT survey and well-localized boundary black hole candidates. Keita, please go ahead.
Hey, could I be heard?
Yes.
Okay, so good morning or afternoon or evening or whatever. I'm Keita Kawabe from LIGO, and I am speaking on behalf of LIGO Virgo Kagura's Rapid Response Team. And I am going to talk about this survey that we have sent. Actually, it was in January. But anyway, before talking about that, I'm going to briefly speak about how and why the rapid response team prioritizes certain type of candidates. If you didn't know, we do such kind of prioritization to, summon experts ASAP to investigate events. And then I'm going to talk about the survey that we have sent about well-localized BBH candidates, which is, one category of prioritization thing. Okay, so let's get started. First of all, from your point of view, this is a brief overview of what the rapid response team does. And we provide the manual processing and vetting of each and every significant gravitational wave candidates. And we issue the first GCN circular, which could be initial circular or retraction. And we have, oops, sorry, what happened? We have literally, hundreds of non-expert shifters who provide collectively 24/7 coverage because, we are a large collaboration, and the collaborators are distributed across, all over the world, basically. And then we have a small number of experts. So the combination of these, non-experts and experts is working towards, this goal of providing manual vetting and sending the GCN circulars. And the rough timeline of the event is that, we issued 2 preliminary notices, which are 5 minutes apart. And this is totally automated, no human intervention at all. And then somewhere between the first and second preliminary notices, the humans are automatically notified and we start human vetting. And then, sometimes there is really nothing, no suspicious thing at all. And sometimes, it takes longer if, there is some data quality problem or something. But anyway, either way, after the human vetting, we send the initial or retraction notice. And this was manually triggered by rapid response team, even though the sending itself is automated. And then after that, we send initial or retraction circular for humans to read. And this was sent manually by the rapid response team. And, sometimes we have to draft the circular. Sometimes the automatically generated template is good enough and we just send it as is. But anyway, so, during the process, there are many steps to be followed. And each of these steps takes some time. But what we have promised to the community is that the human vetting is going to take up to, in this diagram, hours. And we, in general, kept this promise so far. And this is a little bit about details that are related to the survey. But anyway, many binary black hole candidates are only handled by non-expert members. And we have an array of automated tests. And if these tests all pass, we don't have any concern about the candidate. And if that's the case, then the non-expert members can just handle things on their own. But if automated tests don't pass, experts are pinged via, our chat system or SMS or whatever. So in this, cartoon, one of the tests, which is this, pink one, didn't pass. And the non-expert responders find this and then ping the experts saying that, hey, the test didn't pass, please have a look. And the experts are going to investigate. But even if such a thing happens, experts are not exactly obliged to respond ASAP. It might be in the middle of the night for the expert, or, maybe they are, on grocery shopping or whatever. And even though they tend to respond ASAP, they do not have to. So this is a processing of the normal events for the rapid response purposes. However, some candidates are prioritized in that the experts are obliged to start manual vetting immediately. That is, even before the automated tests are complete, to provide their elevated level of scrutiny upfront with the least human latency possible. And so in this cartoon, the probability that the event is neutron star binary black hole, neutron star black hole was pretty high. And the non-expert responders as well as expert responders are made aware of this right away. And the non-experts are going to ping the experts that, this could be an SPH. Come online ASAP or something like that. And the experts will join Telecon right away to start discussing. And these, what kind of candidates are prioritized? The details are explained in the IGWEN public alert user guide. So, please refer to that. But anyway, roughly speaking, these candidates are either coincidence with non-GW events like, GRB or something, or unmodeled burst, or subsolar mass, or it's likelier to be the astronomical origin than terrestrial, and there is a non-negligible probability of being binary neutron star black hole, or that some neutron star material remains outside of the final black hole remnant, or it's likelier to be astronomical than terrestrial in origin, and 90% credible region in sky localization is smaller than 100 degrees squared. And so this is like, our zeroth order or maybe first order guesstimate of what might be of interest to the wider community. And the prioritization is, just a compromise between what we think might be of interest to you and what we can achieve within the boundary condition of our person power. Okay, but what does the prioritization mean to you in terms of human varying latency? And okay, my video is kind of funny. I'll just turn it off. Okay, and sorry. Okay, prioritization eliminates the possibility that an interesting candidate is left unattended by relevant experts, potentially for hours. As I said, the usual or non-prioritized events are also, looked at by experts, but, they are not obliged to respond ASAP, right? But in this case, they have to. But I have to note that even for so-called vanilla BBH candidates, experts tend to respond in low latency anyway. Quite often they are available. Sometimes they are not, but that's okay for vanilla BBH candidates. And the second important point is that the prioritization doesn't necessarily move things much faster than non-prioritized ones. And that's because, after all, we're providing elevated level of scrutiny upfront, right? But despite that, there is no evidence that prioritized events move slower either. And one last bullet point here is that, as the run progresses and kinks in software, hardware, procedures are ironed out, the latency slowly becomes smaller in general, regardless of the prioritization. And this is a really busy scattered plot of the human varying latency for the significant events so far. And we have 200 something candidates. And this leftmost panel is all for A, middle is all for B, and we have only a small number of all for C up to now. The legend is that the blue ones are regular events which were not retracted. Pink ones are regular ones that were retracted. Green ones are prioritized and not retracted. And the orange ones are prioritized and retracted. And so, you can see that at the beginning of O4, there were many, big outliers. There was even the one which was totally off the chart. And things are getting better as we go into the run. And also, you really cannot see much difference in latency between prioritized and non-prioritized, right? And I have annotated like, these four things so that you understand what the prioritization buys you. And so this one, which was not prioritized, this had a big latency due to a technical issue. And, when that kind of thing happens, prioritized or not, things take long. However, if it's not prioritized, there is no guarantee that, the problem is resolved ASAP. And this one, which was prioritized, this had a technical issue, specifically an infrastructure problem. But experts got online to route around that problem ASAP. So, the latency for this was like an hour or a little bit more than that. But this could have been worse if not prioritized. And this looks like it was prioritized, but for the rapid response purpose, it was not. I'm sorry for confusing thing. But anyway, the reason why this is labeled as prioritized is because it was retroactively prioritized due to the finding by Raven that this could have there was a coincidence between this one and the external trigger after 16 hours or something. But anyway, so this is all to say that this was regular event for the rapid response purpose, and it took more than 2 hours, maybe 3 hours or something. And this was because the experts were not available right away. And if this were prioritized from the start, the latency would have been 40 minutes or later. We understand that much, okay? And in O4C, there is a big outlier, but this is a joint event with Swift, and such kind of thing takes more time. Okay, maybe I have to hurry up. Okay, and this is the histogram just to show you that things are getting better as we go from O4A to B to C. O4C doesn't have much statistics to talk about, so maybe I cannot say that O4C is better than O4B, but at least O4A is worse than O4B and O4C. Okay, and now I'm gonna talk about tightly localized CBC candidates, specifically BBH. There is this tight localization scenario that I've already talked about, and this means that even when it's BBH, for rapid response purposes, it is prioritized. And as of April 1st, or as of today, there were 14 tightly localized BBH candidates out of 34 total prioritized candidates. And it's hard at times for rapid response team experts involved. It's not a huge number, but the thing is that it does not, they don't come at a regular interval or anything, right? And we once had, two such BBHs in a row, probably a day apart or something. And when that happened, some people had to wake up in the middle of the night for the BBH, and they were like, oh, this is hard, and we're going to detect it more and more in the future. We're going to die or something. They didn't say that, but there was not that extreme, but that kind of sentiment. Okay, so we started asking ourselves, is it worth waking people up for BBH just because the localization is good? And I, once said to our colleagues that, if I have to wake up in the middle of the night, I want to wake up to something very exciting. And if it's not exciting for people, then why the effort? And so instead of second guessing, we asked you, the community. And this was the first time we asked for your input about anything about rapid response team. And we sent an email to OpenMMA mailing list on January 1st. And we asked you, would you prefer the RRT to keep prioritizing human vetting of well-localized BPH? Would you mind if we lower the area threshold from 100 degrees squared to 30? Or do you have a suggestion for a different threshold? And independent of that, would you mind if we add a 300 megaparsec mean distance threshold or not? And The deadline was Friday, January 17th, and responses were collected via Google Forms. And you spoke, and we really, really appreciate that. Thank you very much. We got 13 responses from 12 individuals covering at least 10 instruments and or collaborations. And, some people were overlapping with others. And it was really great to know that some really do care. The overwhelming majority would like us to keep prioritizing tightly localized VBH. Majority didn't want us to tighten the condition at all. So 7 out of 13 wanted to keep 100 square degrees threshold, and 3 even wanted to increase that to 200. And 3 wrote that 30 square degrees is fine. And 9 over 13 didn't want us to add the mean distance threshold. And as a result, we decided to keep status quo. A tightly localized VBH is still prioritized without changing anything for the moment. And these are just, like pie chart of the questionnaire responses. In the interest of time, I'll just skip this. And so as I said, we won't change the prioritization criteria for now. And for now, our atmosphere, so to speak, is that no expert group feels that this is untenable for the rest of O4. And given the event rate, it's still manageable manageable though, feels kind of hard at times. And if there is a sudden change in the event rate, we will revisit. And in that case, we might ask you more questions like the latency of your response to our tightly localized VBH alerts, if you wait for our initial notice before doing anything, that kind of stuff. And if we change anything about this, we'll tell you via OpenMMA mailing list and update EGWIM public alert user guide. We sincerely thank you, the community, for providing us very useful feedback. And really everybody involved in the rapid response team management are happy about this. And one last note, we expect, of course, more events in O5. So the rapid response team must change one way or the other. We still don't have the concrete idea of how, but early discussions are already starting in some part of the rapid response team. And more announcements and questions might come to you. And that's not just about BBH. That's all. Thank you very much. Any questions?
Great, thank you, Keita. Yeah, if we have any questions for Keita, we have about 4 minutes to take some of those. I do have one piece of feedback that we got. So when you sent out your form in January, Sima started getting messages on Slack from people asking why we were sending out the survey in January when it was over winter break and with the American Astronomical Society meeting happening. And of course, we had to explain that we were not sending out the survey. It was from LVK. Um, but you might have had more responses if the survey was run for longer or if it had been run at a slightly different time. And we're happy to coordinate with you if there's other groups that want to run a survey. Uh, we can send it out through not just the mailing list, but through other channels. So I'm I don't know who the 13 people were that responded, but I'm guessing some of them were folks that I chased down at AAS and asked to send an update.
Yeah, thank you. Thank you very much. That's a very useful feedback. And also, it would be nice if you have the channels that works better than the mailing list. And so in the future, I will certainly contact you if we are to conduct this kind of thing
Yeah.
again. Thank you.
Is there any utility in having a larger experts validation group? So, say more geographically distributed. You can have a volunteer team of experts that are looking at alerts from LVK and doing this vetting. And if they're all around the world, then you won't be bothering people in the middle of the night. I don't know how much training it will take or how if it's even feasible to onboard people into LVK that way, but that might be
Yeah,
one way.
so whenever, there is a chance that the expert group could be expanded, they are already doing, they meaning the expert groups are doing some efforts to expand that. However, you know, some of these groups are very, very small and, only a few experts available for response or something. And that's really not what we can control because, we really cannot force people to work on certain kind of project. For example, I am an instrument scientist and, I really cannot be an expert for specific GW analysis pipeline or something, right? But so the answer is yes, it would be useful if there are more experts. That's a desirable thing. They are uh, doing their part to address that problem, but it's not.
Yeah, limited pool of people.
Yeah, yeah.
Okay. Other questions for Keita? I'll ask one more. I know you sent the survey specifically about BBH candidates. Is there any plans to send a similar survey about BNS or NSBH candidates? Because there I think you will again get a lot more feedback. I think there's a lot of people, very excited about trying to find another kilonova before the end of '04, and so
We are not planning to send a survey for the BNS and SBH in that, in this case, we already know that it's exciting. And so we have never, asked ourselves, is it worth it?
well, but is the other trigger criteria sufficient, or is it interesting to adjust what's actually necessary for RRT even to be less restrictive?
That's an interesting question. I don't have immediate answer for that.
Okay. Um, Well, if we don't have any other questions for Keita, let's thank him and go to our next speaker, who is Jamie Kennea. Jamie is at Penn State and is part of the NASA Across team, which is aiming to provide sort of a single point of visibility information for a whole bunch of NASA satellites that he'll hopefully tell you about in the next half hour. So, Jamie, you should be able to share screen.
All right, thank you. Let me just get my slides up real quick. Okay, look good? Oh,
Yep, all good.
great. Yeah, so yeah, my name is Jamie Kennea. You may know me because I work on the SWIFT mission, but I'm also involved in this Across project at NASA. I'm going to just give you an overview of what Across is, why it was created, and what it's aiming to do. So yeah, here's the background. The Across Core team is the leadership is under the Physics of the Cosmos program at NASA. So Brian Hemensky is one of the chief scientists of the PCOS program, and Chris Roberts is the program manager for Across. As I am at Penn State, as you know, and we also have membership in Marshall Space Flight Center, Dan Kajewski, Michelle Hui, Adam Goldstein, Corey Fletcher, and a bunch of people at Goddard Space Flight Center, which is really a mixture of scientists and programmers. So this is a cross agent across center initiative. So these are the items I'm going to go through. I'm just going to kick right into why this exists. So in response to the TDAM Astro 2020 report recommendation, PCOS was tasked to organize and support TDAM workshops at regular intervals, and we've had 3 of those. to conduct a 3-phase TDAM study, investigate ways to improve coordination with the NASA fleet and US ground-based observatories and internationally, and to recommend implementations for enabling TDAM science. So that study was initiated and by Chris and Brian, and what came out of that initially was this thing called a CROSS, which is the Astrophysics Cross Observatory Science Support Pilot. So the idea here is that we have a whole of fleet approach to TDAM by providing organizational, workforce, and technical infrastructure. And this involves NASA's operating missions and those in development. And our aim is to enrich and support the broader TDAM ecosystem. Really, the idea here is to try to take a whole fleet approach to TDAM, to try to make missions that are generally not considered part of the TDAM infrastructure part of it, and to try to make the barrier for entry a lot easier. So yeah, this is our mission statement, which I won't read out, but it's pretty much what I just said. So how will Across achieve its mission? So we have science feasibility tools, modern target of opportunity resources, a web portal, and a community engagement and innovation program. Let's talk about those. So one of the problems we have right now when you're trying to figure out, say some exciting event just occurred, and there's a lot of activity going on, missions observing it, missions putting in TOOs, what missions would be good for observing this, can some missions see it? Right now, in order to assess this, you have to kind of go to about, a different website for each mission, and the information available on those websites is extremely heterogeneous in nature. For example, if you want to look to see what Swift is observing tomorrow, we have an API, but which is nice. But if you want to do the same for Hubble, you kind of have to go to a text file, and it really depends on the mission. And we want to try to sort of flatten that and make it universally available. Target invisibility, again, if you want to calculate feasibility and visibility of targets to a particular observatory, there are some tools available for doing this, but they're a little antiquated and don't really take into account kind of the full capabilities of missions. And equally, if you want to plan like coordinated observations, there's no easy way to do things like I want to observe this target with two spacecraft at the same time. And yeah, also, we're interested in looking at sort of wide field instruments. I mean, we have right now Fermi and Swift making wide field detections. So, we want to be able to say if an exciting event, say we get a boat goes off, quickly be able to say which of these instruments was it in the field of view of at the time, just to sort of look for the coincident, detections. With oncoming things like currently with things like tests, that's a useful thing to know if it was in the test field of view when it went off. In the future, we'll have Roman and LSST and things like this, which again will be often sort of accidentally observing interesting things as they happen. So we want to be able to provide that information. And also we want to do this for sort of ground-based observatories. Right now, at the start of the project, we're kind of targeting NASA facilities because NASA facilities are, for us, the kind of low-hanging fruit. And as this program is kind of guided by NASA headquarters, those provide us the easiest kind of collaboration opportunities, although, some are easier to collaborate with than others. So we're building these feasibility tools, and they're going to be available as open source software on GitHub, and we'll deploy them both as a web application, but also as an API. So there'll be full sort of like modern standard RESTful API interfaces for accessing this information. So that's really there to enable the kind of computer to computer calculation and feasibility of things, which is being enabled by right now the Swift API, and try to extend that to all the other missions that currently don't really provide that kind of capability. We're looking to modernize TOO resources. So again, Swift, the model here is Swift. We have a TOO API. People are using that API in interesting ways. For example, Sky Portal and the Tom Toolkit have their own implementations of a client for the API. So you have, so if you want to submit a TOO to Swift, then you don't have to just go to the Penn State website to do it. You can use Sky Portal. We can submit TOOs. Tom Toolkit can submit TOOs. So this is a model. It's a kind of, if you build it, they will come. And we want to be able to implement this for more missions. So we're building a sort of generalized version of the TOO system that was built for Swift, built with slightly more, shall we say, professional software practices than deployed by just myself. And the idea here is that we can provide this to missions and say, okay, if you want a TOO, if you want a TOO page, here is a modern implementation of a TOO page, which does things like calculate visibility on the fly, but also has like API interfaces built in. Because and one of the reasons why I want to do this is because we're looking to a future maybe where NASA missions doing TDAM have lower funding profiles. So you'll have things like Starburst, Black Cat, these kind of CubeSat and SmallSat missions. They don't really have the money to implement, a fancy API and a fancy TOO page. So often they go sort of to the simplest route, which is just building a kind of pretty crappy web interface. We've seen this with NASA missions. So we're trying to provide a kind of a first-class product that they can roll out at no cost to themselves. So we're enabling the sort of what I've spent years developing at Swift and are now kind of redeveloping with Across, cheaply and easily for NASA missions. And this is going to be wrapped up in what we call a TOO toolkit. We have a web portal that will be online. All of this, I should say, all of this is going to come online in October. We're still sort of in the development phase, and our coming out party should be around the time of the 4th TDAM workshop. But the web portal is there to provide kind of useful information for TDAM observers about NASA missions, funding opportunities, conferences, links to missions, and resources. So the idea would be that would be your jumping off point. We will have dynamic content, so we'll have our API, we'll have applications on this website built upon that API. So if you want to do things like, hey, who's observing 3C273 next week? Or hey, I want to observe this target. Which of these observatories are going to be able to observe it in the next 2 days? You can do all that via our own implementation of sort of API clients. And we'll have a help desk, which is there to kind of assist in people trying to enable TDAM science. The idea here is that we're going to have a bunch of people on staff that are kind of experts in this field. And if you look at that list of people on the first page or second page, we already kind of do have that. And they'll be there to enable people if they want to, have help. Say, I really want to get JWST time, or I really want to get Hubble time. How do I go about doing that? That will be there. And of course, all of our software is going to be open source on GitHub once we get the NASA approval on that. So we'll be there to take community support and PRs and whatever through our GitHub. So yeah, the last part. Community engagement. Well, is that the last part? It's not the last part. Sorry, there's 4. Community engagement and innovation programs. So as we talked about doing TDAM workshops, and indeed Across is organizing the 4th TDAM workshop, which will be in Huntsville in October. And it's part of this program to continue to support those workshops. There will be funding opportunities. So we have a bunch of different concepts for how we can fund projects. The whole idea here is to incentivize the community engagement and innovation in TDAM areas. So we'll probably be having funding opportunities for developing like software tools. Back in the TDAM workshop we had back in Tucson, I was very much focused on software tools. And one of the things that we heard loud and clear there was that people wanted more funding opportunities and more consistent funding for software projects. So we hope to provide some of that. And you know, we want to participate in community-led activities. So you know, OpenMMA, good example. We're already talking with Aeon Plus folks. We're talking with the folks on Acme in Europe. This is not a takeover by NASA of anything. The idea here is that we are a good community player, and we are providing an implementation of a service which others can plug into. And we expect if we do a good job at this, then this will provide much needed input to other people trying to do like kind of the same thing. So you know, we very much are believers that you know, multiple activities are a good thing. Having more data out there and better ways to access the data is a good thing. The benefit of Across right now is that it is funded and supported by NASA, which means it has a relatively stable, hopefully, funding profile. We will see in the next few years if that continues to be true, but we are hopeful. And I'll note at the Committee on Astrophysics meeting in DC last week, the acting head of SMD Astrophysics, whose name escapes me right now, did specifically call us out as something that they are supporting. So we're pretty hopeful that that will continue. Okay, there wasn't a fourth one. Okay, so quickly I'm gonna just go through this example that we did in the last year, which was was to support the BurstCube mission. So the BurstCube mission was a CubeSat which was designed to detect gamma ray bursts, and we wanted as a CubeSat, they were limited in many ways, not the least of which was their ability to do science operations, you know, additional kind of information that, or build websites like we've been talking about. But mostly they were interested in doing a thing that's kind of similar to the Swift Guano program. So Guano is one where we downlink data from BAT kind of you know, on demand. So we have a bunch of missions and other facilities like LIGO, Virgo, Kagra detecting events. And you know, Swift is designed to kind of trigger itself, but it's also recording data all the time. And we want to be able to download the data for those events based on what other people saw as well as what we saw. The trick with Swift was that the data only exists on the spacecraft for 25 minutes, so we had to do a bunch of novel things to get the data down. With BurstCube, the data would have existed on the spacecraft for like 24 hours, I think, but they still needed to have a prioritized list of events for them to downlink. So that they could prioritize, you know, what was interesting in the data and what they should just leave on the spacecraft, because they couldn't downlink every event. It was too much data. So we developed an MVP, a minimum viable product, to try to increase the science return of BurstCube, and by doing this, we learned a lot about interacting with the community and interacting with missions and everything else. So the idea here is that we have built an orbit propagator for BurstCube, so we know where BurstCube is. We understand the instrument and field of view and sensitivity, and we understand observing constraints such as, you know, what's being occulted by the Earth and whether the mission is in the SAA. The brokers, basically GCN, were providing the alerts, and every time an alert came in, the probability of the joint event was calculated. And what we ended up with was a list like this, where each event, as you can see, has a calculated probability that the event was inside the BurstCube field of view. So, you know, in the case of LIGO, Virgo, Kagra events, this was taking the HillPix map generated and convolving it with the field of view and seeing what the integrated probability inside the BurstCube field of view is. So that way the BurstCube team could take that information and say, oh, okay, this LIGO event was like 100% inside a field of view, so we should definitely download this one, or this one was mostly occulted, let's not bother with it. And the same was true for like other, shall we say, less well-localized things like Fermi GBM bursts and also triggers from missions like Swift and others. So yeah, do we download the data? yeah, so the whole point of this was to come up with a workflow that really increased the scientific capability of BurstCube. So as it turns out, BurstCube was relatively short-lived. It had a lot of problems, but they did in fact detect several GRBs, and in fact I believe a couple of the ones detected were identified using this process. So although I think as a development, this showed the success of this kind of project that we're doing. And we're now going back and kind of trying to build this in a formalized way that we can apply to many different missions. So we'll be doing this similar sort of job for like TESS and Fermi and Swift and all the NASA missions. And we hope to have essentially a nice go-to web page where you can really see like what's going on with the whole fleet, and just make everyone's lives easier. And then other people want to do this for other observatories can plug into our system and grab that information as well. All right, so status of this. Well, we've implemented our agile software development process, so that means people who actually know how to develop software are working on this, so that's good. And we're actively working through NASA's open source release process, otherwise known as doing lots of paperwork and doing a lot of red tape. But we do anticipate launching all this in October of 2025. And will be hosted on this new site. The way NASA hosts its data like seems to move frequently, but the current thinking is science.data.nasa.gov, which doesn't exactly roll off the tongue, but that's the new rules that have come into place in the last few months. This is a schedule that we're on track. Great, everything's going to work. So let's just talk briefly about the fourth TDEM workshop. Across is organizing this. The theme is community-defined coordinated observing concepts for rare and important transient events. And the motivation here is to define and prioritize science cases, triggering criteria, and the essential follow-up observations, ground and space, public and private, desired by the community so that observatory science teams can pre-coordinate plans and efficiently execute community-driven observations. Should get them to put some punctuation in that. So the idea here is that we're working with a bunch of observatories like Hubble and stuff, talking about can we have predefined TOO programs for events that are rare? Because we know that there's this problem in the community where people write proposals to observe things that don't happen very often, and you have to write that proposal every year, and it almost never gets triggered. And eventually, the review panels are like, yeah, we're not going to bother approving this because it's never going to happen. You want to write the proposal for the galactic supernova, or for whenever T Corona Borealis is going to blow up, or the next boat. It's hard to do, but we all know that rare events happen, and we want as many observatories as possible to provide follow-up, and we want that to be community driven as well. So this is the topic we're currently we just convened the SOC to talk about invited speakers and science topics. So this is well underway, and that's it. Any questions?
Thanks very much, Jamie. Do we have any questions for Jamie? Oh, Jen?
Hey, Jenny Driggers, the LIGO Science Collaborations Operations Division Chair. One thing that I've been wondering is if there's a centralized place, and if there's not, could this work toward being that of longer term, like just a place where observatories put their long-term observing plans so that, if the LBK is trying to fine tune when O5 starts or ends or something, how can we maximally line that up with observatories that might be interested in observing target of opportunity type things? So is there a centralized place that has all observatories and their general years-long observing plans?
Yeah, it's an interesting question. I mean, essentially, we do intend to be a clearinghouse for as many observatories as we can get into our system. So the idea is to have long-term plans and short-term plans for all the NASA missions and any other missions and ground-based telescopes that we can integrate. The question of like planning over years, though, is an interesting one because I'm not sure that, I mean, most missions will have plans sort of developed maybe for like a year in advance. So it's not clear to me, like, are you talking about whether a mission will be in existence or will be available at a particular time, or what?
Yeah, more like Rubin, my understanding is it's got a 10-year mission. So just having a big bar chart that says like Rubin starting approximately on this date, going for approximately 10 years.
Yes. Okay. Well, that certainly is one of the pages on our website that we've been developing so far does in fact have a chart that shows you the existence of all the missions and all the observatories that we work with, and you know what their planned sort of existence timeline is, as much as we know it. Of course, for NASA missions, that tends to be, you know, up to 3 years in the future, because that tends to be how they're rescheduled. I mean, for things like JWST, obviously it's longer. But yeah, that will certainly be part of it. For, you know, we're looking very closely and actively working on you know, integrating Vera Rubin schedules into our system. So you know how that plays out is you know, we'll see. I think the important thing here is that we're working towards a sort of initial release which has short and long-term plans for all the missions, the kind of an overview of the missions and when they're expected to run to. But you know, this is going to develop, there's going to be further capabilities developed in the future. So if there's anything that you think you want there that you don't see, then feedback is appreciated.
And Jenny, if I can quickly add a little bit to that, for experiments like Rubin that I'm part of, the schedule for the next night is usually known in great details. The sort of broad plan for observatories in the sense of which program has how much time is often known for maybe only a semester in advance.
Yeah.
And then even bigger plans like how long this mission's supposed to, like the bar chart sort of thing, that may be known for a few years in advance. But the detailed thing about where a particular telescope is pointed is maybe known at most only a night or two in advance. Some facilities like LCO make this information available, but recompute it very often as well. Brian?
Hey, Jamie. Thanks for a great talk. Good to see you again. So, I've voiced some concerns about these community trigger things in the past, and I appreciate that you're having this TDAM meeting specifically for that. I think that's fantastic and, you know, the right approach. But I wanted to just sort of ask a more general question about funding related to that, because, for instance, JWST and HST funds are administered through Space Telescope, whereas SWIFT or whatever else is administered through NASA. You could imagine some, you know, maybe there's some NSF funding being thrown around. How do you think that would all work? And then sort of a secondary thing is, right, like, I can imagine there being a lot of preparatory work to make sure that you can produce the appropriate community plans for these events. And do you think that through Roses or something, there would be a call for funding proposals to do that preparatory work?
Oh, okay. Interesting questions. I can probably say that, yeah, I mean, the reason why we're having this meeting is because these questions exist and we want to be able to discuss them at the meeting. So, you know, we're, in terms of plans of funding, we've been having discussions with Space Telescope about how we would do this with Hubble and JWST. I would say the how the funding part works out is a very interesting question, and we've certainly discussed the idea of you know, if there's a community TOO program where it's the community that's asking for the data, then the funding will come out sort of through a proposal process, perhaps, where people are saying, I propose to do this work on the data that's public. Of course, the data will be all public, in all likelihood, and that's a whole other can of worms. But there've been initial discussions with both within our team and with the folks at Space Telescope about how this would work. But it's a little too early for me to give you an answer on that. I think, again, this is something that will come out after the meeting, when we kind of really sort of nailed down the science cases and how we want to implement it. So probably a little too soon for me to give you an answer on that. In terms of sort of preparatory grants, it's an interesting question, and I haven't actually considered it. So consider that put on the list of things that we're going to consider.
All right, I'll say you could imagine that being part of this call for software as well.
Yes, absolutely.
All right, thank you.
Yeah, no problem, Ryan.
Ryan, just one more quick point to your comment about cross-agency funding. At the NAS meeting that Jamie mentioned, we did hear from NASA, but despite the meeting being in DC, unfortunately, the DOE program officers, Kathy Turner, Brian Field, and the NSF program officers who were initially supposed to come, Chris Smith, couldn't make it in person, despite, again, being on DC. They couldn't make it on Zoom as well. So I think a lot of this will also is connected with science policy in the country, more in the US more broadly.
Yes. That's all above my pay grade, so any of this probably.
We live in interesting times. Do we have any last questions for Jamie? Okay, well, if not, we are basically at time. We are already scheduling next month's OpenMMA meeting. I know one group has already expressed some interest in presenting. There is another slot. I'm hoping that we can have an update from Rubin Observatory, which should have first photon next week. But if not, if there's another group that wants to present, please let us know. We'd be happy to schedule you. And I look forward to seeing you all in May. Bye bye.